Good morning students, I am your Nagini ma'am. Today I am going to discuss about the mole fraction based question students, how to find easily mole fraction based question. See students, here what is the mole fraction of the solute in 2.00 molal aqueous solution given, 2 molal aqueous solution given. Are you following? Here unit you observe properly students, small m, that is molality. Are you following? Molarity is represented by capital M. Molality is represented by small m students. Okay, how to find it? Now see students here. So how to find it? Here how many molality given students? 2 molal, correct? 2 molal. So that means what is the meaning? Molal means the number of moles of the solute present in the 1000 grams of the solvent, correct? That is the molality. Are you following? So molality means what students? Molality given. It is m, small m. Understanding students? This is the solution. So molality is equal to what students? Here what we can calculate? Molality is equal to formula n by V, correct? Sorry, N by W, weight of the solvent. This is which one students? Weight of the solvent. Number of moles of the solute present in the 1 kg of the solvent, correct? This is how much students? 1 kg. Okay, now it is in kg. Okay, now 1 kg of the solvent, weight of the solvent. So that means here 1 kg. Solvent weight is how much students? 1 kg. Solvent weight is equal to 1 kg. 1 kg means in grams how much students? 1000 grams. Are you following? Solvent weight is 1000 grams. Okay, no. So weight we know that solvent weight, and solvent is which one students? What is the solvent? Aqueous solution. Aqueous means what students? Water. Clear? Aqueous means water. So that's a what molecular weight is how much students? 18 kada. So then we can find the molality. Solvent weight we know that. Solvent molecular weight we know that. Then we can find the number of moles of solvent. Are you following? Because mole fraction of the solute we have to find. So what is the mole fraction of the solute students? Formula: mole fraction of the solute, correct? That means solute is equal to what is the formula students? Number of moles of solute by number of moles of solute plus number of moles of solvent. Clear this one? This we have to find it. Then how to find it students? Number of moles of solute, how many moles given here? 2 moles given. 2 by number of moles of solute, number of moles of solute 2 plus number of moles of solvent. I don't know, I have to find it. So number of moles of water is equal to weight of the solvent, means 1000 by number of gram molecular weight of solvent, that is 18. So 1000 by 18, how much students? This value is 55.5. Okay na? So this is the number of moles of water. So number of moles of solvent, how much students? 55.5 nana. Okay na? Then how much you will get? 2 by 55 plus 2 means 57.5. Okay na? 2 by 57, 2 by how much students? 2 by 57.5. Then you calculate once. 2 divided by 57.5, how much students? 0.034. Clear? This value is 0.034. Okay, so this is the number of moles of water. Are you what students? What we calculated? Mole fraction of the solute kada. So this is the mole fraction of the solute. That is the question students. Mole fraction of the solute is equal to how much nana? 0.034. Clear this one? So this is the mole fraction problem students. Understood this one? Okay now. See students, in this question, which of the following electrolyte has the same value of Van Hoff factor as that of aluminum sulfate? If all are 100% ionized students, okay, all are 100% ionized. Then how to find it, the same value of Van Hoff factor? First you find this all the components Van Hoff factor. This also calculate students. Then which one is same? That is the option. Okay, now first I am going to calculate aluminum sulfate. So what given? Al2SO4 thrice. So first take Al2SO4 thrice. It is dissociates into ionized. Ionized means it is undergoing dissociation. Are you following? It is undergoing dissociation. So how many aluminiums are there students? 2 aluminiums. How many sulfate groups are there students? 3 sulfate groups are there. 3 SO4. 2 aluminiums, 3 sulfate groups are there. Now charges you should write. Aluminium charge is plus 3. Okay now. Aluminium charge is how much students? Aluminium charge is this one. Sulfate charge is this one. Okay now 2. That means here aluminium charge is plus 3. how much? Plus 3. Sulfate charge how much, students? How many aluminiums are there? That number will go to the charge, sulfate charge, that is minus 2. Are you following? 2Al plus 3, 3SO4 minus. Total how many ions formed here? 2 ions, so here 3. Total how many ions, students? Total 5 ions. Are you following? 5 ions. Then what is the Van 't Hoff factor, students? How to find it? Van 't Hoff factor is equal to total number of ions formed, okay na, after the dissociation by total number of ions produced before total number of ions before dissociation, okay, total number of ions before dissociation. So after dissociation how many ions? 2 plus 3, 5, by this is before dissociation how much, students? 1. So total 1 only is there, so 1, 5 by 1, I is equal to 5. Now these compounds also you calculate, then which one is same you will get, okay na. So this is the first one. No, this is question only given, okay, that we calculated. And next one is aluminum nitrate, AlNO3. This is the first one, students. Then how it is dissociate, students? Aluminum only one, 3 nitrate groups are there, 3 NO3. Aluminum charge is how much, students? Aluminum charge is 3 and NO3 charge is 1. Are you following? So NO3 charge is 1, students. So NO3 thrice, okay, 3 moles of NO3. Al charge is how much, students? Plus 3. NO3 charge is how much? Minus 1, okay na. Total how many ions are formed here? How many ion? Here 1 mole kada, 1 plus 3, total 4 ions are formed. Are you understanding, students? 4 ions are formed. Then I value, how to find it, students? I is equal to for total number of ions after dissociation 4, before dissociation 1, so I is equal to 4. So this is the question is aluminum sulfate, its Van 't Hoff factor is 5, and in this 4 options which is having 5 is asking, so it is I is equal to 4 now. So this is wrong option. Now I am going to calculate the B option. See, students, B option, K4 FeCN6, correct? K4 FeCN6, potassium ferrocyanide, correct? Potassium ferrocyanide. See, students, how it is dissociate? How many potassiums are there? 4 potassiums. FeCN6 only 1 is there, correct? So 4 potassiums, FeCN6. This potassium, how many are there? 4. So that's FeCN6 minus 4 charge, but FeCN6 only 1 molecule is there, so that's a potassium charge is plus 1, okay na. Total how many ions are there? 4 ion. This is 1 ions. Total 5 ions are there, correct? Here total 5 ions after dissociation. So I is equal to 5 ions by 1. So how much, students? I is equal to 5. So this is having the 5 ions. Aluminum sulfate also having the 5 ions. So that's why option B is the correct one, students. Both are having the same same Van 't Hoff factor. Clear this one, same Van 't Hoff factor. And one more C, D options are there. C students, C value. C potassium sulfate kada. Here I am doing, students, C option. K2SO4 potassium sulfate. How many potassiums? 2 potassiums, 1 SO4. Potassium charge is how much, students? Sulfate only 1 is there, plus, and sulfate charge is 2 potassiums are there na. This number is comes to the charge of sulfate, SO4 minus 2, okay na. Then total how many ions, students? 3 ions. 2 here 1, 3 ions by total before dissociation 1. So how much, students? 3. I is equal to 3. So this is the this is also wrong. Are you following, students? This is wrong. Understood, Amma? So this option is wrong. This option is wrong, okay now. Next, coming to last option, K3 FeCN6. See, D option, what given? K3 FeCN6. How it is dissociate, students? K3 FeCN6, K3 FeCN6. Total 3 potassiums and FeCN6. FeCN6, okay na. Potassiums 3 kada, so that's why its charge is minus 3. This one charge is plus. Total ions 3 ions potassium, so here 1 ion. Total 4 ions. 4 by 1 I value how much, students? 4. So this is also wrong option. Are you following? So this is wrong. Which is correct one, students? B option is correct one. Clear this one? So this is based on the Van 't Hoff factor problem, students. Like this you have to find it.